it contains many different games. So all of these things on the left are games that people can play, and some people have played it. Some people, some games have been played. Some games have not been played. For example, this looks to be a game that Jukka has finished some years ago. Somebody else has tried, but no result. Some games have been tried by many people, but not successfully being completed. But what we do have situations where many people have played are the SciFest events in different years. So these are, so SciFest is an event where many people, usually students or smaller kids, come to see different scientific applications, and we have been there every year for the last, was it 6 years maybe, with this O-Mopsi game where they have been playing it, and it is really the time when we get most of the users in Mopsi. So you can see this 2016 also played by many different people, and then 2015 also has been played by different people, and so on. The other games that are not SciFest, some of them do have some players, but usually it is not so much. So most of them come from these organized events, and some of them, depending on their popularity or how interesting they are, they did manage to attract some players, but not really as much as we would hope for. So this O-Mopsi is a gaming platform. It has all of these things here are different games, and the purpose is to solve this orienteering problem. So, for example, this Christmas star game, it has 10 different targets that you can see here on the map. And what you have to do as a player is to go there and find all of them as quickly as possible. So you have to go out in the real world, you have to understand the map, where you can and where you cannot go, where streets are available, and then you need to figure out this route, what you're going to take, and then actually do it, get close to each of the targets, and collect all 10 of them in this case. The app is very simple. I don't really think you need it to be demonstrated. It simply shows on the map your location and all these different targets, and it will update your location and leave a trail behind, similar to our app that we developed in this course. At the moment you are approaching a target, you get a sound notification, and then the target disappears, leaving you with 9 targets in this case. And the game finishes when you have 0 targets remaining, and at that point you are ranked by time on this kind of list, and the top 3 are emphasized in some way. After the playing is complete, you can analyze different statistics and different trajectories here. So this is the winner of this game, and we can see that it is a very long game in the first place. It is about 20 kilometers of moving around. So it took quite long, also almost 2 hours of this is running, so somebody was running very fast. Right. Not a very simple game. It's quite hard to play this one. Maybe we can look some smaller example. I know that this Kanervala game is also played by different people. Maybe an easier variant of the game is also here played by different people. So this is smaller. We can see now that this is less than 3 kilometers distance between them, but still some challenge in the result, and pressing the different players here reveals some different order. So not everybody is playing the game in the same way. Everybody is choosing a different order, and then between the targets, between each target, there is also the question what roads to take. So of course you could consider going from this one here, maybe this way that you see here, but why not go this shorter way? It seems to also be possible. So depending on the player's knowledge of the surroundings, of what streets are available, and also what is displayed on the map, they may feel comfortable to use some shortcut, or think that they can manage to find some shorter way than the others. But being fast is not the only thing that is important here, because you can be extremely fast and choose a very poor order. So it's also a puzzle game in the sense that figuring out a short way quickly gives you an advantage, because then you don't need to be as fast as somebody doing wrong decisions. So you will finish the game faster because your distance will be shorter. So if we check now our evaluation here, this first ranked player has traveled a distance of 2.5 kilometers. The second player closer to 3 kilometers. So you might argue that with this time difference, it may be that choosing a different order, this Jukka guy would have been even the first if his decisions on the street, on the road, would be better than the first one. So it's comparable speed, but not necessarily an optimal path. And then this player has also 2.5. This one less than 2.5. So even better order seems to come from here. And Latari has some mistake here. It is over 3 kilometers, but still very good. But it also shows here, so she was not necessarily much slower than the others, but because of this extra distance, maybe difficult to find a target here. It seems to be the reason, because looking on the map, you can see some kind of difficulties in this area. This kind of moving, turning around indicates that the person is not able to find a specific target easily. So getting lost, or stopping to read the map, or not being sure where a specific target is, this adds up to the playing time, and also to the distance usually. If you make a mistake, then you need to fix it one way or another. So it's definitely not a simple game. Does anybody know this problem, this traveling salesman problem? Have you heard of it before? Yeah. So it is essentially it. What we have to do here, it is we have a set of targets, a set of locations, and you need to find a path that connects all of them and is as short as possible, or as short as you can get it. And this traveling salesman problem is not a simple problem. It is a difficult problem. It is actually in the class called NP hard. And this just means that we don't have any polynomial time algorithms that give us the solution, the correct solution to this optimization problem. The correct solution is a length, a path to follow that is the smallest possible. You can never find a smaller one than the one that you have returned. And there are several algorithms for solving this. Of course, the most, maybe we let's take this SciFest game from previous year. And we have here implemented many different algorithms on the top. And each of these tries to solve the problem in some way. Now, the simplest way that you can guarantee that you are going to find the optimum order is to try all of them. Now, how many orders can we try here between all of these targets? Well, first of all, you have to choose one target. So where do we start? You can start here, or you can start here, or here. But actually, you can start at any of the 14 targets in this one. So this is our first choice. And we have 14 different options for the first target. Now, after you choose one target, let's say this one, then you have to choose what is our next target. And we have different options for that as well. So how many? Well, it can be any one of them, but there are 13 remaining, so we have 13 options for the second target. And then this goes on and on until we are at the end, so we multiply this by 3, 2, 1, and we have a number which usually is simplified by this exclamation sign, and this means 14 factorial. It means the same as the number of permutations that you have for 14 different items. And this number is very big, so 14 factorial, it's not a small number. If we take the calculator and we see how much it is, it's a big number. So 87 billion tries. So we have to try 87 billion ways of finding all the targets here. Of course, computer is fast. It's going to do this very quickly. But how quickly? This is now another question. It's you could say that, okay, maybe my computer does 1 billion calculations every second. So this is a very, it's okay computer, 1 billion computations in 1 second. But here we have 47 billion. So, okay, that means roughly, okay, let's say 27 seconds. So it's a relatively long time. You have to wait for it for a while to get the number. But this is now only our situation with 14 number of targets here. So what if instead of 14 we have more? What if we have 30, for example? So this is also common in O-Mopsi. I think we have games that are almost 30, maybe like 27 targets or more targets anyway. So let's say we have 27 targets. 27 factorial is now very, very big. So if the billions are somewhere here, okay, not very good marker. But anyway, the value here on the left, this 10, 888, 869, stopping here at the 160, that's how many seconds your computer would need to solve this problem if it is going to try all of them one by one. And that means a few years. So you cannot use such a simple algorithm in practice. It will take too long time. And because of that, other techniques to solve the problem have been implemented. And we can see a few of them from the top here. The first one, this ACO, it stands for ant colony optimization. I don't go much into the detail of how it works, but basically it's inspired by nature. It's an algorithm inspired by nature, where multiple ants spread and try to find different targets on the map, and they leave a pheromone trail. So this pheromone trail is some chemical that other ants can see that, okay, this trail seems to be fresh. So if an ant goes to some path and then comes back and the trail is still fresh, it means that this path has been shorter than a path of another ant who has also went somewhere and came back in some other order, in some other direction. So ants, many ants in a group will learn from each others and find a solution that is getting better and better the more that you iterate this algorithm. So, in short, it is based on this kind of aspect, and it does find some solution. It says that, okay, it seems to be 1 kilometer and 365 meters if you could go in a straight line. So now this is a little bit of a difference, because in practice maybe you are not able to jump over Arena here. So Arena is a big building, and maybe if you can fly, or if you are playing with a drone, or if Arena has a door here and exactly a door here, then maybe you could get such a short way. But most likely it is not possible as a human to get exactly this length, assuming that this is optimal. So it's possible also that this ant colony optimization did not give me the optimum solution here. It's possible that the ants were just not efficient enough and they couldn't find the best possible solution. In that case, maybe it could be done by human better. So if you as a player are better at solving this problem than a bunch of ants, basically. Now, another algorithm is this taboo search. It is very similar to this idea of trying out all the possible combinations, but at some point it will mark some combinations as taboo. It means I have tried this before and it doesn't seem to produce good results, so I'm not going to try a variant of this in the future. So this taboo is just a way of trying out different combinations, but not continue in a place where it doesn't make sense to continue based on some heuristic. So it tries multiple combinations, but marks some of them as there is no point to continue there. And it also works, but depending on this heuristic, like how do you decide when there is a point to continue or not, you will get a better or a worse algorithm, or a faster or a slower result. So in this case, using this taboo method, we got another path, slightly different, this blue line on the map, slightly different than this orange one, and a little bit longer, about 100 meters longer. It seems to do this detour here, whereas the orange path seems to prefer this kind of zigzaggy approach. So it's just an output of the methods. Seems that this ant colony is a little bit better. Now, this BB method stands for branch and bound, and it has a guarantee that this will produce the optimum. So I am positive that this branch and bound is going to give us the best possible result. I'm not going to give you too much details about how it works, but it's a variation of the brute force. So it tries again all the possible combinations, but like the taboo, it skips some of the places where it is not, where there is no point to continue. Just to have an intuition, if we have already a solution from ant colony, let's say this 136 meters, we found this maybe randomly. We just tried to find a combination, and we find a solution that is 1.3 kilometers. And then this branch and bound, maybe next time it's going to try to calculate one of the possibilities. For example, to start here and then to go there and then to go there and then to go there and then here. This is a valid starting point if you must try all the possible combinations. But you can put you can put now this information that I have found 1.3 kilometers before. So what do I have at the moment? Well, this seems to be something like 1 kilometer already. Now this back seems to be 800 meters. Now this there, another 800 meters. So I already increased some solution that I found previously in the past. So there is no point to try from here to go all the remaining possible combinations, because I have already found that there is no point to continue due to the length that I have so far. So a bit confusing, but it's yeah. So idea is just to try to cut the solution space so that you don't expand when you are starting with a bad solution already. So try to reason, is there any chance to get a better solution from a specific place or not? If we have time at the end, I can give you more details about this one if interested. But I just want to point out that this is not a very simple problem, and that good algorithms like this ant colony and taboo still have problems. It seems that this branch and bound found even better than the ant colony a little bit. Not much, but 3 meters. 3 meters difference. And I think we can see here the difference a little bit. So I think that it is, yes, so this link probably, I will turn taboo off because it's overlapping a little bit. So this link here and this link here are the differences between ant colony and branch and bound, and probably it means that this one here is 3 meters less than the orange one. So it seems to be the only difference between the two results, but still it is a difference that the ant colony algorithm could not find. So what I want to say here is that this branch and bound is going to become more and more computationally intensive as the number of targets is going to increase, but the ant colony will stay the same unless you add more ants, for example. So this is another parameter there. But it will not guarantee the optimum, whereas the other one does. So there is a trade-off here, and because we know that even for this small number of targets, like this 14 number of targets, these algorithms are having problems, we can say that this is indeed a difficult problem. So the efficient algorithms are not able to find the optimum. They are able to find close to optimum results, but not really the optimum. And the ones that do find the optimum are going to increase in exponential growth. So they will become more and more lengthy, like we saw that calculation here. I just increased the number of targets from 14 to 27 in this example, and yeah, the execution time changed from a few seconds to many years. So it is the reason that this is classified as an NP-hard problem, and it is also why we decided to make a puzzle game out of it. If computer has this much problem figuring out what is the right order, then probably human will also have some difficulties with it. And it's true, because if we go back to the main page, it is also the reason why different people have different orders of visiting these targets. It is because they each think that another one is better and worth to follow. So it does seem that it is a good puzzle game in the sense that there is a lot of variability in the solving of the game. Right. Any questions, and are you interested to know more about these algorithms for solving the problem? Because I don't want it to be a focus, I want the application to be the focus and the features in the application, because that's the purpose of this course. I just wanted to give a brief idea of why this is a difficult problem and why we made a puzzle game out of it. So,
who had all of these targets?
Yes, I will get to that now. Okay. Now, I mentioned here that we have many games. How many games we have created? 154. And the games are distributed more or less over the world. We have on different continents even. Most of them, however, are in Europe, and the majority of the games are in Finland, and of course the vast majority in Joensuu, where we have quite many of them already. These 67 games seem to be in Joensuu area. We use crowdsourcing basically when creating these games. It means that any user, any Mopsi user, can create games if they want to. And what the targets are essentially photos or services that we have in Mopsi. So to demonstrate this, I will show you now this own games feature, which has in my situation, it has all the games that I have created for others to play. So any user can create games for other people to play, and I will show you how you can do that using this system. And spoiler alert, it's not very easy. This is one of the bottlenecks of our situation, of our game, is that it is very hard to find good targets in different places. And I will demonstrate by trying to make a game in Kuopio maybe, because we don't have as many targets in Kuopio as we have in Joensuu, for example. So I'm going to press now this new game button, and let's call it a name. And after that, I have here on the top 3 possible ways of finding targets to add onto the map. The first one, it looks in the Mopsi photos collection. So if I press on it, it's going to load my pictures from Kuopio. So these are pictures that I have taken in Kuopio. And we can check to see which ones are good for being targets or not. This one, not that great. It's an indoor photo, so person might need to have access to inside the house. I would not put this as a target because of that. This has the same problem, so no point really. Now, here it seems to be the marketplace area, some nice flowers, but will these flowers still be there if I create the game now, or are they there even now, because this picture might be old, might be from some longer time ago. So these kind of problems are preventing O-Mopsi game creation to be very easy, but some of them are okay. For example, this could be a target. So it seems to be a small lake in the center of Kuopio, and this small apple tree, I guess, it is there. Maybe the ducks are not there anymore, but the tree is very likely to be still there. So I can use this as a target in the game. And to add it there, I have this add goal button here. So I'm going to put it here into the list, and I can change the name maybe to something like apple tree, and goal name has been updated. So, okay, let's try to see something else. Maybe this place, it seems to be some, I don't know what, is it hairdresser? I don't know if it is still there, but I could Google it and find out if it is still there existing, or maybe some other service has came after it. These are problems. We don't really have a very good way to select these different targets, but we try. So,
what do you think? About that? Why don't you just put the position to the target?
Yes. Okay. Very good point. I will get to that after I demonstrate a little bit more.
I'm early bird. I'm early bird.
No, it's a good question, because I would maybe forget to mention it, because we have considered so many different things in this game that I cannot remember all of them. So if you have questions, just ask anytime. It's
good. Thank you.
Yeah. So I try to add also this target here, and maybe let's add something else. So I seem to have a picture of this post place. I don't know if it is still there. Maybe because I see here on the Google Maps a mark for the post office. So that gives me a bit of a confidence that maybe this photo is still valid. It hasn't changed much.
Yes, I was there at the post office.
Yeah, maybe.
No, maybe. It's there.
Have you checked today?
Yeah. Last week I was there.
Okay.
42.
Okay, great. Right. Why we are using photos? So the reason is that when you are playing such a mobile game, safety is a problem. I think many of you have heard some news, like in Pokemon Go, some people got hurt, or also other of these location-based games. If you are walking around and looking always at the mobile phone, the more you look at it, the more likely it is that some accident happens to you. Like maybe you are walking on a red light, or don't look where you are going and you might step in some dangerous place. If we have a photo of a target and you are playing the game and all of a sudden you see this next target is going to be a tree and it's next to a lake, then looking on the map, you have maybe an idea. Maybe you are here, and you are making a plan that, okay, I'm going to have to go this way, but then the streets end, and then there is this green area where I can go any direction, but I'm looking for a tree that looks like this. So you can basically play the game with the mobile phone in your pocket, because this picture helped you figure out what you are looking for. And it says a bit more than just if you read the text apple tree, because apple tree can look like our example here, like that, but it might also look like that. So depending on what you have seen there in the picture, you know what you are looking for, and it reduces the amount of time that you are watching your phone screen. It may not be very much, but it does affect a little bit. So we think that the same happens for everything. If you see a picture of this post, for example, then you know that you're looking for a building that has a higher floor here, and maybe this post is visible on one of the sides. So you notice this kind of feature in a few seconds of looking at it, and then you are simply scouting for this location, for this kind of features that you see in the real world. So that is why we think that having a picture is very important. But we have tried, we have tried, for example, I have made this game which is based only on text. So the targets have a text description saying what you will find there. It is possible you don't need a picture there, but it is not as easy to play a game using this kind of targets as the photo is. You have to stop and you have to read that text and you have to figure out what it can be, or yes. Is this a bit answering your question?
No at all.
Not at all.
I mean, why don't you just put that there is that kind of coordinates, just a pointer there, marker?
Because then you have to look at the map all the time until you are sure that your location is going to reach that other location.
Yeah, but if this was the orienteering game, just go to the forest like a real orienteering.
Yes, yes.
Orienteering.
Yes, but the problem is that in the forest, the real orienteering is played very frequently in such a way that before you go playing orienteering, somebody has to make a game for you. And somebody has to go there and put for you one target here, and he has to go and put one target there, and he puts one target here, and then he has to go home and he has to make a map and print it with multiple copies for you and give it to you, and then you have to take money and pay that map, pay for buying that map to play the real game. And if you want to play this O-Mopsi in the forest, it is possible, but all trees look the same. So the idea is that we want the targets to be objects that are there for a long time. You don't need the person. Yes. You don't need the person to go and put them into the forest every time you want to play and take them off so they don't get destroyed in the rain. And then to give you a map, you want a map that is always going to contain the targets, and you want the targets to have something visible, that they know that they are there at the location. Of course, in orienteering you have these markers. You know that you have found the location, but somebody puts it there.
Yeah, but why here we put the pictures?
Yes.
Why they don't have to be Could they have to be the just the targets, just the rocks and that kind of side or position?
Yes, you mean that on the map you would have just a picture of a target?
No picture, just because the Foxy computer, he can get the knowledge of the GPS coordinates and said that the target is there. And there it could be that just a little text that rock or like a horizon.
Yes, okay. So instead of having the real flags there, you will have this kind of marker on the map, on the mobile phone. That says, yes, it is possible. You can make a game like that. But I have to ask, is it different when you say that you have found a place in the forest, it doesn't have anything there, but your phone says that it has something there? Is it different than if you find something real, a real object, and you know that, okay, I have found this. I have found basically this thing somewhere outside, and I have it here, and I know now that yes, I did find something. I didn't just find an empty place in the forest that the phone thinks is something there, but I did find a target.
Yeah, but if we compare it to the orienteering, there is just the flags. What you try to find,
yes,
it's enough for many of us.
Yes, but the flag is there. You have found the flag.
But okay, I don't know. We have to make a researching that is the virtual flag enough. Yeah,
it's true. Okay, another thing is that when you are looking at these, when you are playing suunnistus, when you are doing the sport, many times the map has details about how the location looks like.
Absolutely.
For example, you might learn that that the flag is expected to be here on the top of a mountain, or maybe that the flag is expected to be in a hole, hidden somewhere, so very difficult to find.
Yeah.
Okay, so these kind of situations also exist if you have a picture. So if you have a picture, the environment of what that object is, you understand it from that picture. You understand that, okay, this tree seems to be in the middle of a very open space. So it's a very visible target. You understand that the post sign is on the side of a building, but if you are on the wrong side, you might not see this target.
Yeah.
So basically it is not the same if you have just markers on the map and you're looking for it, because your problem-solving skills use the environment, use the information in that picture to find it faster. You're always solving some problem.
That's true, but if we have that kind of ideology that the path to the target is the game, not the target. And you have to make a lot of calculation how to get the target. And it's just a little part of the game. I don't know.
Yes, I can say that it adds to the game experience something. It's maybe you are happy enough to find the targets like this, just on the mobile phone. Yeah. But other people, if you think, okay, this tree is in open space, I know 2 places with open space in the area, I just go quickly to both to see what they are, then this is already another level of problem solving.
Okay, but if we compare to the Pokemon, there is the virtual animals or whatever.
Yes.
Many of people are keen of these.
Yes. We will talk tomorrow about that.
Good.
But very good point. We also have one more reason for doing this, is that every year when we went to SciFest, we had this feedback form. And we asked the people who were playing what they liked about the game. And one of the top scoring things that they liked about the game is finding the target. So we know just from small group of people, but I think that cumulatively this small group of people is maybe maybe 100 people have given us feedback over the years. We know that they like to find the target. So finding a target should mean something to them, and not just this location on the map that they have reached. I can argue that if you are given any location, like this place, and if you know your location at the moment, anybody can figure out that, okay, I try to move, seems that I'm moving in that way, it's not very good, so let's turn a little bit to the right, and then you can continue to move that way, and eventually you will be able to find this. But if you have also photo information there, and maybe in this place you see that in the photo you maybe have a glimpse of this horse track there, then your mind can already at the beginning say, I know where that is. So I'm going to go directly to that direction. So basically you are problem solving through the information that you get through the game. More information came, how it looks like, and then you immediately figured out, I know where that is because I recognize the horse track in the picture. Even though the picture might be of a statue or something, and the horse track could be just in the background, you still recognized part of it. So mind is always working, even when you are running around. It's okay. Question really is, why are there so few very popular applications out there? They have very small things that make them appeal to large audience and to the media, and they just became popular, but nobody really knows why. They just have guesses. And one of the guesses could be this, that using a real object there has a better impact than using a fake object. So it's hard to say if this is really a thing that could make the game more popular or not, but it seems that because people like to find the targets, report to us that they like finding the target, and this difference in gameplay is not the same as not having it there.
If you compare to the virtual Pokemon emoji, why the people are so excited about these?
Well, we can talk later about it, but I think I can already mention some differences. So in Pokemon Go, okay, first of all, target audience. So question about target audience. Who is this O-Mopsi game? Who is the target audience for this O-Mopsi game?
Maybe the what are they who's coming to get the sightseeing? Tourists. Tourists.
Maybe tourists, yes. Maybe tourists. Very good. Okay. Who else is the target audience?
And jockey. Who jogs?
Okay. Should you be a good jogger?
No.
Okay. What happens if you are a bad jogger?
It's a good training.
It's a good training, but do you get as much stimulation to play the game as the good joggers who will eventually be the first or the second or the best ranked players? I mean, do you like to be on the second half of the result list?
No, but I used to be.
Yeah, okay. Me too. So, okay, target audience, I would say, yes, tourism is important here. So if you are a tourist, then the game can act as a sightseeing guide, as a tour guide. It tells you different places to go. But alternatively, it's a competition. It's a game where you compete to be the first or to be very good. And this is very different from the principles in Pokemon Go. In Pokemon Go, the idea is that you are rarely losing something in that game. You are always winning things in that game. The game is about collecting objects. It's about collecting as many objects as possible. And you don't need to be very fast to do that. You can even go collect something today and then go in the afternoon with the bus somewhere else, collect something in that other place. You don't need to jog there. There is not a restriction on this physical fitness of the people that are playing the game. But there you get the benefit that the more things you collect, the higher your level gets. So you become better by just collecting more and more and more and more. Here it doesn't really matter how many games you play. It just matters how is your score within the game. So we reduce the target audience to far less people than what Pokemon Go is doing. If you have a disability, if you don't have legs, you can play Pokemon Go with no problem. And you are not necessarily going to be disadvantaged. You can move some other means, not necessarily by running or like that. So target audience is very different, and the goal of the game is also very different. Okay, I think we can have. Do you want break or do we stop after 25 minutes? Okay, let's continue. Just talk about this and then we stop after 25 minutes because I don't think a break fits right now. And this is not too intense. I think we just talk to see the differences and why something is good and why something is bad. But I understand why you are telling me that this marker is enough. Because creating the game, you need picture, you need content. You need that content to be good, a good picture, and you need it to be actual, to still exist today. There are these problems. And what happens if I want to create a game somewhere in Norway? I have not been in Norway. I don't have pictures there. It's a big problem. And that is probably why you are insisting in this direction. But we just think that the quality, the experience, the gameplay is much better if it includes the picture of the location in a picture at the location. So it's a compromise. Do you want to have a better experience when playing, or do you want to have the ability to create not so good game experiences everywhere? It's like a balance, I would say. And we are looking at ways how to do this automatically. So I mentioned now this way of creating the game using O-Mopsi photos. So this place here. This is very similar, but it uses the O-Mopsi services. So here you are limited to restaurants, hotels, or different services. Of course, somebody else might have taken the picture of the service and create the service into the system, so the database is a bit bigger. We also have this option where if you have a picture of the area, then you can drop it here, just drag it there, and then after that you can still fine-tune this location on the marker if needed, but it's even more difficult. You need so many clicks and not very nice thing to do. We have also experimented other databases. So most of these games that you see here in the published list, they are made from, okay, now I'm talking about games that are in other cities, like this one, for example. This fits into what you said before, this tourism category. So this is I would say, a touristic game. The different targets are different sightseeing places in Barcelona in this case, so different like cathedrals or statues or so on. And we have got them from open libraries that contain this kind of information. So I believe that this info we got from this service. This web page called A View on Cities. I don't remember the details exactly, but to my knowledge, Pasi contacted the owner of this service, and they are, if I remember right, they are pictures that he has taken or that people that work with him have taken, and they have collected from different countries and different cities. And Pasi asked, can we use it into the O-Mopsi? So then our database grew with another set of information for these touristic objects. We still have problems with that because you have the picture of the object. So this can be quite okay. Just a second. So maybe you have a picture of the object. In some situations it can be very easy. Maybe you have the map here and you see that the object is there and somebody took a picture from this angle. So then the location of the picture is going to be here. So this is going to be the GPS information, right? Now, in this situation, you are maybe 2 meters away from the target. But it is possible that, like if we go back here and we take maybe this target, then the distance to this target is maybe going to be something like 50 meters. So I'm talking now about the place here where I am, where the user's location basically. So the user is somewhere there, but the actual object is elsewhere. So person is expected to do what in this case? To find the place where the picture was taken from, or to go to the object, maybe the main entrance, or what do you do in this kind of situation? And how do you find the main entrance from the photo that has the location information, but it's the wrong location information? It's the one of the person who took the picture. Many of
yeah. Who made the roads, these game roads? Is there some kind of operator or you or some?
Who made all these games?
I mean, if they are crowdsourcing these pictures, yes, but who made the roads between the pictures? Some operator or you? Okay.
Who made the who made the roads?
The roads, the connection linked to the picture, the game.
Oh.
Who decided that this is in your game?
Well, in this case, Pasi is the creator of this game, and he created most of them.
Yeah. Okay, Mr. Pasi. He just get the picture, place the Charles PS, and then, okay, I am about 150 meters away, the point of the Charles PS, where we can get the knowledge of the position, key GPS position where the building is.
Mm-hmm.
Yeah, it's not difficult to just measure that.
Yes, I know, but this is if you have taken that picture. Now Pasi created this game by using some external source, like this website, who gave us their database.
Yeah, but you said that
yeah.
You said that there is the 2 meters to the statue.
Yes.
And then I said that there is about 150 meters to the building. And Google knows where the statue is and the building.
Yes.
Then we can put the calculation.
Yes, you can do, but you have to spend a lot of time and effort to do it.
Yeah.
It is not an easy tool. It's not a tool that you just press a button and a game appears.
Yeah. Is it that way that these routes, what are the links to these objects, these targets, are they coming just from the pushing the button?
The routes, do you mean this?
Yeah.
This is not something that appears in the game. This is something that the player has to find.
But what's the order? How it goes?
There is no order.
You just go through the targets.
You can go any order.
Oh.
This is the difference from the typical Suunnistus game.
Okay, there is no any. Yeah, what's the name of the game?
Okay. There is no. I don't think there is equivalent, but maybe Lahari knows. Does Lahari know? Is there such a game existing already, or is it just our variant?
Is it that way that I start with boxes?
It is more like this geocaching kind of game.
Okay, and I start the game and find the object, and then maybe if I want to, I go to the second one, and there is comes to the.
Yes.
Okay.
Yes.
All right.
So that is. I should have started maybe with that, but.
That's the reason there is no any customers.
Aha. Okay.
There is nothing.
Okay. So you think that because the order is not there, it is not the same as soon.
No excitement any at all.
Well, it's debatable because I think that it allows you to find your own order.
Yeah.
And,
is it that the first man or woman goes these targets, and then the second one comes? Is it there? And he or she try to compete it.
Yes.
Yeah. Okay.
So, for example, we have this system here. Maybe this one. It makes a simulation of how the different players on the right have played the game, but it considers them starting at the same time. So, for example, I could select here that I want to see Jaani, and maybe I want to see this person, and maybe this person, this person. So I have now 4 different people on the map at the same time, and when I press this play button, I'm going to see how they move, what is their order of finding these different targets, and this could. It's already indicating that, okay, it seems like maybe this person is now having an advantage, but the last one is also catching up. But if you look at the map, the orders are different. So that means that they will have different distances at the end. So of course, if you give them where to go first time and where to go the second time and the third time, then it is like Suunnistus. You only have to think about what is the path to connect the two different targets, but everybody will have the same order in the end. But I think that the interesting thing here is that the more you think about solving this problem, the shorter path you are going to find to connect all of them. So it is a compromise between thinking more and running fast. You might think more and have to run, and then you can run slower, but you will still be in the top of the list. Or you can start the game without thinking. You can run very quickly, but then you have to deal with any mistake that you have done. Like if you forget one target somewhere, or if you optimize some improper way. So it does seem like you have freedom in this game compared to the typical orienteering, but it comes with a price.
What is the price?
It is that you might have to run more than the other person, and you will lose not because of your speed or because of your ability to find the targets, but because of your inability to choose the right order at the beginning. So this multiple level evaluation of the players. Right, but anyway, I will still show you a few features here, because I think we started talking a lot about this target audience, and I still want to show some of the features. For example, okay, maybe something that Lahari has been working on. So if we take some player here, was it in this TSP or this the one for the mistakes calculation?
You just try that button, but it is not yet completed. But not this one, that glass is.
This?
That one, other one. That search button.
Search.
Beside that chart button.
Beside
this one, yes, this one.
Oh, okay.
So.
Okay, so it's.
So this will show. You just try again. I think it will show something, some numbers.
Okay. Okay, but not yet on the.
On the roofs,
map.
yes.
Okay, so it's still under construction. Okay, is this also when it was previous time? Or?
No, previous time.
Okay.
But those were confusing, I think.
Yeah. Okay. Then I mentioned something else. Then this kind of this complexity calculation is also here.
Yes, it is.
Yeah. So it says here a value for this game complexity. And what do you think means game complexity? So what is an easy game and what is a difficult game in this kind of situation? What would you consider a difficult game?
The targets are further apart.
Okay, so far away.
More targets?
Yeah, but like it's difficult to find the optimum route to all the targets.
Difficult to find optimum route.
Yes.
Okay.
To like traverse through all of them.
Okay. So far away. This is the first thing. I will go one by one through them. So I would say that yes, far away is a problem, but it's more it's a problem for your fitness level. So it's not the overall difficulty of the game, but it's physical difficulty. So some people are comfortable running for tens of kilometers. Some people are comfortable running for 1 kilometer. Definitely, the difficulty is coming also from this because you are doing it in the real world. So this difficulty, this feature, the the distance between the targets affects this difficulty. How about what you were saying now? So about the difficulty of solving the order. What makes it easy or hard to solve the order?
How they're spread out.
How they are spread out, right? Is this game that I'm drawing here difficult to solve?
No.
No?
Straight line.
So what if this is 1 kilometer? How hard would you say that this game is? It seems to be a total of 5 kilometers if you go in this order and then you solve all of them. Okay. How about if this is 10 kilometers? Then this is 50 kilometers, like total distance. So this affects not your logic. Everybody is probably going to play the game starting here or starting here, right? And then just going in one line, it's not too difficult to do this. But now solving the game logically, this starts to be a bit more interesting. So you said how they are spread out. I'm going to try to find some tool here. I don't. Okay, I remembered it. So do you remember or do you know what the minimum spanning tree is? Okay, this is the minimum spanning tree. It is a tree that contains more or less the shortest possible of combination of links that is connecting all of them. Now, we have noticed that there is a correlation between how complicated this minimum spanning tree looks like and how difficult it is to find the optimum order. So in this case, in this case, because this tree is not linear, so this would be a linear tree. Okay, the tree here looks linear. This is more easy to find the optimum order than if I make a modification like this. So I just moved one node from up to down, but this instance here is more difficult to solve than this instance here. So visually, somehow people are very easy find out this solution here. I don't know if it is optimum or not. Maybe here it could be like this and it is better, but it is very close to optimum. But if I make a small change, like, okay. But if I make a small change and only moving this one here, then people start to be already confused. Like, okay, I somehow don't see this pattern anymore. It does start here like the same way as before, maybe, but then do I go here like this, or do I go that way? So it's somehow. And then what do I do here? Because this link seems to be quite long compared to maybe this link, but I can't take both of them because if I do, then I have this loop here. So this is according to how many branches and how complicated this minimum spanning tree is, and you can get it quite complicated, I think so. So the more of these branches that are appearing, it somehow indicates that there are more options at that level. So we found that based on this kind of configuration of the minimum spanning tree, which you can calculate very quickly, it's much more easy to calculate than the TSP, you can have an idea of how difficult it will be for the people to solve the game. It's not a perfect correlation, but it is there. And we have found that by looking at the distances of people that are playing the games, and also and their playing time, and also this configuration of the targets. So we have taken the different games that people have played, and we wanted to see how far or how long it took them to solve more than the optimum. And then we also looked how do the targets look like. So yeah, this has been, and this still is kind of unsolved problem, but we have a pretty good idea in which what makes a complicated game and what makes an easy game, and so on. Is this confusing a little bit? They are not, I don't want to go too deep into why something might work or not, but yeah, any game should have a difficulty level, because like what we mentioned before, not everybody can go very far distances. So this is one setting, how far the targets should be from each other. But also here, the more complicated the game layout is, it is less likely that you will have, for example, small kids, be able to solve it efficiently. So you can see this kind of situation happening in SciFest, for example. Very often you get some kind of, okay. This seems to be not so difficult game. But last year I think it was a bit more. Yeah, so maybe here, in this example, I don't think this is a very good solution for the game, even though this Jani guy played multiple times here. He liked the game and he wanted to be better and better and better all the time. I think that he could have gotten much better time just by finding a different order for the targets. So he became better and better by running more and faster and learning where they are. But I think that probably going this kind of order would have been better, because you see here he is basically going all the way down just to come back up again. So this indicates a problem in the logic, in the thinking of the game. So this length here and this length here seem redundant. It would be much better to go, for example, like that, and then after you collect this one target from here, you don't have the need to go the long way back. So this is not necessarily a very difficult game, but definitely the MST here is not linear. It probably looks something like this. Something like that. So it has a knot here and it has another knot here. So it causes you, it puts some questions, and you have to think what would be the real solution here. But this is it puts a lot of pressure on the players. So players need to also start the game very quickly, because if minutes start to go by just thinking about the order, then you're losing precious time. So in Pokemon Go, because you asked before, there is not this much pressure. Here you begin to be evaluated already when you start to do the first step. Did you go in the right order, in the right direction? Even if you don't do any step, you are evaluated like, why are you not moving? Are you thinking too long? So this is not the same type of game where you get instantly bonuses and prizes and things all the time coming to you. This is a much more competitive game.
Is it why do you want to why do you want to get the order? Is it important to get the knowledge of how to human resolve the order?
Well, I think that this is a problem that everybody is facing in everyday life. If you are going to go now, well, after I finish work today, I probably go shopping, and then maybe I have, well, today is a bad example, but maybe you go to some place in like pharmacy, and then you want to go shopping somewhere, maybe you have some doctor's appointment, and then I don't know, some legal issues, and you need to visit 5 different things quickly, and they might even have time limitations like opening hours and so on. So really what you're doing, you are thinking, how could I do this so it takes me the less time?
What do you think, is this a correct measurement to measure the time if the order is so?
Yes. It is correct, because time and distance together, they form the speed. And the speed is just an evaluation of how fit the person is. But it is completely separate from the problem-solving part. So you actually evaluate different things. And Lahari now, she is wanting to make another result here. Another result which ranks based on the order. He wants to see who is the smartest or the most patient people, because of course it is arguable that even guys who are doing unnecessary long trips, they could find a better solution if they spend 1 hour to solve the game. But time is ticking, so it really combines these two aspects. But at the moment we only rank based on time, and this is a problem, because if you rank also based on the quality of the result and the optimality of the result, then we have more people who are winners. And people like to be winners. So it is very likely that maybe, let's say this Ganesh or Jaan or somebody might become the next 1 or 2 in that list. So this would be more motivation for them to play, even though they are not, they know that at the moment others will be faster. They see, okay, but I am better in this list. So they might still win it, and then maybe they get the idea that I'm the first, I published to Facebook, and then friends of that person might learn about the game and so on. So these kind of features would help, I think, to make it more likable. But it is a lot of effort to implement, and at the moment we are not so many people here doing it, so it takes time.